Lesson for today will be looking at Chemistry 1502. The topic for today is resonance structure, lesson 103. Let us start. In lesson 101 and lesson 102, we've discussed what is resonance structure. We also looked at how to represent resonance structures. So in this lesson video, we'll be introducing new concepts so that you understand this chapter better. The new concepts are going to talk about major and minor contributors. You have to know these terms when you're dealing with this. And then we'll also be introducing the electronegativity of atoms when choosing the major and minor contributors. In the previous lesson video, we also talked about the types of arrows that we'll be using in this topic or chapter. Now, today's example that we'll be using to explain the concepts, the terms that I've just covered, it's this one, HNO3. So let us start by drawing our first structure for this type of compound. You can see that it is not a polyatomic ion, so it doesn't have any charges. So we're going to put our nitrogen as the central atom. I'm going to start by drawing or testing the correct structure. So let's say we put our hydrogen here, forming a single bond with nitrogen. Then we can see hydrogen, it is satisfied, and then we put the remaining atoms around nitrogen. So in this case, you can see that once we start by calculating the formal charge of each and every element here, we are going to have hydrogen as our 0, nitrogen, because it has bonded 4 times, as positive, oxygen be negative, negative, and negative. Since they form single bond with nitrogen, you can see that the overall formal charge here will give us -2, because it's -1 minus 1 is -2 minus 1 is -3 plus 1 from nitrogen will give us -2. So this tells us this is not part of the resonance structures, because you can see the overall charge here is 0. So you should not consider this as part of the structures. So you can see that formal charges, they play a significant role when coming to drawing Lewis dot diagram. So let us start by aligning things different now. Instead of bonding hydrogen directly to nitrogen, let us do it like this. And then we form a single bond with oxygen, forming a single bond with hydrogen. So we connect hydrogen to one of the oxygens. Then from here, since we formed a single bond with oxygen, we only need this. So we put the remaining oxygens here. Now in this case, let us look at the formal charge. How can we go about to get the overall formal charge of 0? So we know that the formal charge of nitrogen, in this case, it will have a 0 formal charge, provided we put our lone pairs here. And then our oxygen here, since it is bonded 2 times, it will have lone pairs. Then the formal charge will also be 0. So we're going to have 0, 0, 0, and then here we're going to have our negatives. But you can see that the sum of this formal charge will give us -2, of which we are not looking for that. So we can do something with nitrogen, because we can see that once we break this, we are going to have -2 here, and of which we don't have to tamper with the sigma bonds. Like I said on the previous lesson video, we cannot tamper with this bond. We cannot break them, because they are the ones which are responsible for the unity of these elements. So what we can do from here, how about we form double bond? This comes here. Remember, we are not trying to draw a resonance structure, we are trying to draw the first structure of this compound. So if you can draw it here, we are going to have something like this. Now the formal charge of this oxygen, since it has bonded 2 times with lone pairs, it will be 0. And then since nitrogen bonded 4 times, it will have a positive charge. Now you can see that this plus this will definitely give us 0. So this structure will actually help us to generate other structures. So we can just fill in the lone pairs, and then yeah, it is correct. So this is the first structure of HNO3, nitric acid. Drawing the resonance structure of this, we can start pushing the electrons. How about we take this electrons, we push them here, and then we take this double bond, this single bond from the double bond, push it here. Then we can see that we are going to have something like this. No, it is a single bond with oxygen. The formal charge here will be negative, and then we have double bond here. We have only lone pairs here. Then we haven't tampered with this one. Then you can see that we said from Lewis dot diagram 5.2, if oxygen bonds 3 times, it will have a positive charge. So here we are going to have a positive oxygen and a positive nitrogen. Then you can see that the sum of formal charges will give us 0. Drawing the third resonance structure, we can push these electrons. These ones, we can push them here, then push these electrons here to form we no longer have double bond here. We have a single bond, and you're going to have lone pairs and hydrogen. And then we have double bond here, and then we have lone pairs. Then we haven't tampered with this one. Then this will be positive. You can see that the formal charge of these elements will also give us 0. Now we have structure number 1, structure number 2, structure number 3. In terms of formal charges, we can see that structure number 1 and structure number 2, most of the elements, they contain formal charges which are close to 0. Looking at structure number 2, you can see that we have many elements that has non-zero formal charge. So structure number 2 will be considered as a minor contributor. It minorly contributes to the correct structure of HNO3. Now let us compare 1 and 3. Which one contributes majorly? Though we can see their formal charges are almost the same, but let us look at this. 1 and 3 will contribute equally. When we look at these structures in terms of electronegativity, structure number 2, it is still not favored when we look at this in terms of electronegativity. If we are to compare 1 and 2, their formal charges, both of the structures, they add up to 0, but 2 will still contribute minorly, because if we can look at the formal charges of oxygens, we compare oxygens. This one has 0, this one has -1, this one has 0.
Looking at this one, we have negative 1, and positive 1. Looking at the electronegativity of these elements, oxygen, it is more electronegative. Negative charges, they tend to be claimed by the most electronegative elements. Looking at this typical example, just to explain the concept of electronegative. Let's say we have structure 1 and structure 2. You can clearly see that they both have positive and negative formal charge. Now in this case, if we want to check the major contributor of this resonance structure, we'll have to look at the electronegativity. Oxygen, it is more electronegative, so it would like to claim the negative charge. So looking at this compared to a typical element R, which is less electronegative compared to oxygen, you can see that the major contributor in this case will be structure number 2, because you can see that the more electronegative element claims the negative charge compared to this one. So if it happens that you get to a situation whereby the formal charges are more or less the same, like for example structure 1 and 2, but in this case you can see that we don't have an oxygen which is positively charged when it comes to formal charge. But if it happened that you had something like that, whereby let's say this one, it is positively charged, we will look at the two structures and check. The one that has a positive charge on an element which is more electronegative would be the minor contributor. Based on this concept of electronegativity, there is lesson 104 whereby we look at those examples. That's it for this lesson video. This is Wabula SJ. Thank you very much.